Part B. Calculate the average rate of disappearance of A for each 40-second interval in units of moles per second. So, average rate is equal to the change in the concentration, or the change in the amount, over change in amount over the elapsed time. And since we report the rate as a positive value, we have to make that into we have to get the negative of that, because the concentration of a reactant is going down, so the change in concentration is negative. So if you want the value to be positive, you have to put a negative before the expression. Okay, so let's do 0 to 40 seconds. So the initial amount, or the final amount, so average rate is equal to final amount minus the initial amount over the elapsed time. And again, we have to make that to negative so that we have a positive value. Alright, so let's do this. The final amount, the amount at 40 seconds is 0.067 moles, minus the initial amount, the amount at 0 seconds is 0.100 mole, and the elapsed time is 40 seconds minus 0 seconds, and you should get 0.000825, and this is moles per second, and that is negative. Next, we do from 40 seconds to 80 seconds. So average rate is equal to, again, final minus initial over elapsed time. So that would be 0.045 moles. The moles of A at 80 seconds minus 0.067 moles. Moles of A at 40 seconds over the elapsed time is 80 seconds minus 40 seconds. And you should get 0.00055 moles per second. Next, 80 seconds to 120 seconds. Average rate is equal to amount at 120 seconds is 0.030 moles, and amount at 80 seconds 0.045 moles, and the elapsed time is 120 seconds minus 80 seconds, and get the negative of that. And this one you got to get the negative as well. You should get 0.000375 moles per second. And finally, from 120 seconds to 160 seconds, average rate is equal to final minus initial, again 0.020 moles, minus initial is 0.030 moles, and the elapsed time is 160 seconds minus 120 seconds. Get the negative of that, and you should get 0.00025 moles per second. So you look at the rate of disappearance of A. 0 to 40, it's 0.000825, and then 40 to 80, it's 0.00055. And you notice that as the The reaction time increases, the amount of A left, the rate of disappearance decreases. So that is true for chemical reactions. The rate of reaction decreases with time.